Hi, my name is Adam Hessler. I'm a student in Physics 2, and this is my long term on the effects of fatigue and shot velocity. And whenever I refer to shot velocity, I'm referring to a soccer shot. And what I did in this experiment was I basically simulated a couple penalty shootouts, as we'll get to in a couple slides here. So my claim was that the maximum shot velocity will decrease as a person becomes more fatigued. Again, so just the more and more they run or sprint or whatever, the less shot velocity they'll be able to generate. In our case, we generated fatigue just by running miles. So I ran from 0 to 10 miles for my data points, and my brother Jay, who also did this experiment, just ran from 0 to 5. And again, this is just how we define fatigue. So when you see miles, it's just fatigue. Our procedure was that we took 7 trials, or in this case, each trial represents a shot after each mile, and we started from 0 and just went from 10 or 5. And then we had a video rolling for each of these 7 shots, and I measured the time between 2 distance markers that we had laid out in the frame of the video, and then calculated the velocity by dividing the distance by the time. So again, this is a picture of my setup. So we have these 2 strings that were a constant 10 feet apart, and they were just distance markers for the video. So the string to the right was tied down to the tripod, just so it was anchored down, and then they were both taped down to the floor of my driveway. And then the second string to the left was tied around that cinder block, and that just served as a marker so I knew where to put the ball each time I was taking a shot. Also, not pictured in the pictures was that I used a goal as a backstop, so I wasn't running like a maniac in between miles to go and get the ball. I just walked over like the 10 or 15 feet away the goal was and picked up the ball and walked it back to the spot. When Jay did it, I was out with him, and then I just got the ball out of the goal for him and threw it to him. So this is a video of me, that was a video from the tripod of me just shooting. Again, this is a constant 10 feet in between the two strings, and then I used a video recording to measure the time. So that video was in real time, so it was really hard to see. So what I had to do was slow it down to 1/5 speed to get the most accurate time. And then once I calculated that change in time, I just converted it back to real time and then calculated the velocity. So to slow it down, I just used the Video Shop app on my phone. These 2 pictures show what that app looked like. So again, the video of the shot you just saw on the previous slide, that was for my experiment at 0 miles, and this was trial 5. So again, the first picture to the left is just me initially making contact with the ball at 7.27 seconds. I kind of ignored the minutes because everything that happened was basically under a second or a little bit over a second. So in that second picture is the ball whenever it's meeting the edge of the frame and the string at 8.09 seconds. So I just subtracted those 2 values of 8.09 and 7.27 to get 0.82 seconds, and then from there I converted it back to the actual time by dividing it by 5 and got 0.164 seconds. And then lastly, I took my constant 10 feet and divided that by my real time of 0.164 seconds to get an average velocity for that trial of 60.98 feet per second. So these are the data tables from Jay's data. There were a few things interesting about his data. I wanted to include my data tables also. The problem is that I had 10 miles, so I had 10 rows, and there was just like a lot there. It was very hard to read, so his are a little easier to read just since there was less data. What was interesting about Jay's data was that if you look at in the 0 mile row at trial 2 and trial 4, those 2 0.66 values, I didn't have any like 0.66 values on mine. Mine were all either in the 0.82 range or in the 0.99 range, which was also similar to his for the most part. There were a little variation between those, and I think that's just showing that the shot velocities are very discrete just in their nature. So another interesting thing about Jay's data was that if you look at mile row 5 at the bottom for trial 2 and trial 3, he has those 2 values of 1.16 and 1.15. I also didn't have any of those values. They were all either approximately 0.82 or approximately 0.99. So again, it shows that there were 4 very discrete levels being shown here. It's the approximately 0.661, the approximately 0.821, and the approximately 0.991, and the approximately 1.151. Mine only showed 2 of those levels, and I think that was just because Jay's a better soccer player than I am, so whenever he first started shooting, before he had ran at all, his shots were going to be faster than mine on average, and then since I have a little bit more of endurance shape than he does, by the end of his experiment, he was shooting at slower levels than I was. So this data table is just the real time, so it's just all of those values on the previous table divided by 5 for each of them. And this last table is the velocity, so I just took my constant 10 feet and divided it by the real time. This was Jay's graph. For these graphs, it just kind of put everything, all of the trials and the averages onto one graph. So you can't really see anything from here. You can kind of see that it's, decreasing slightly linearly, but I think that's more apparent by the averages from each mile. So as you can see, at 0 miles, his average was roughly 65 feet per second. And then by the end of it, at mile 5, it was down to approximately 50 feet per second. Contradictory to that would be my data, which was a lot more consistent, and it also had a lot more data points. So you can't really tell from this graph with everything on it, but from the averages you can see that it hovered right around 60 feet per second for pretty much the entire time. I think you could argue that it was starting to decrease towards the end, but I don't think it's that apparent of a decrease to conclude that. So in conclusion, fatigue does cause a steady decline in shot power for your typical athletes. In my case, I think years of endurance training kind of assuaged the effects, and it would have been better if I could test more people. But due to the circumstances, I really couldn't. But also, it was cool to do a long term on running because it's something that I've always wanted to do, but haven't really got the chance to because it's during the school year. So it was kind of a blessing in disguise that I got to do this project on something that I really cared about and combine it with another sport that I really like, which is soccer. So that's my long term.